All right, so let's go on to our last problem now. A researcher wants to compare two brands of insect repellent. She finds 30 volunteers and asks each one to spray one arm with repellent A and the other arm with repellent B, determined by a coin toss. The volunteers then spend an hour in a forest preserve at night. The researcher counts the bug bites on each arm afterwards and records the data in the following table. Conduct a hypothesis test to determine if there is a difference in the efficacy of the two repellents. Use the alpha equals 0.05 level of significance. Okay, so what type of test are we doing and why? So the first thing that we have to notice is that we have two samples. Right? One sample is the data from repellent A and the other sample is the data from repellent B. However, these two samples are not independent of one another. If I enter you to be in the study and I spray one of your arms with repellent A, then you are going to be in the study for repellent B as well. So since everyone that is in the study for repellent A is in the study for repellent B also, the samples are matched pairs. Or dependent. So because we have two samples and they're matched pairs data, and this is numeric data, we are going to do a paired t-test. Okay. So now, what's the null and alternate hypothesis? For a paired t-test, the null hypothesis is always, well, the null hypothesis in general is always no change, no difference, or no effect. In this case, it would be there's no difference between the two samples. So the mean for repellent A is equal to the mean for repellent B, the mean number of bites. Or another way to write that is that the mean for repellent A minus the mean for repellent B is equal to 0. And that's how we're going to do a t-test, because we have to deal with just one set of data in a t-test. And that's what we're going to do. We're going to say, all right, I'm going to look at the difference of the two means and say that that's 0. What we're trying to figure out, the researchers trying to see if there's a difference between the two bug repellents. So we're going to say that the mean for repellent A minus the mean for repellent B not equal to 0 is what we're trying to show. Okay, and here's how we're going to do this. We're going to enter all of this data into our calculator. Okay, so here's the data, and what it is for each subject, they have a repellent A number of bug bites and repellent B number of bug bites. So we're going to enter all of the repellent A's into a list and all the repellent B's into another list side by side. Now, normally I would say use L1 and L2, but I've already done this ahead of time and I already used up L1 for something else. So I'm going to enter the repellent A data into L2 and enter all the repellent B data into L3. And just so that you don't have to sit and watch me enter all of those values, I'll just show you that I have them in there. Right? So if we go up here and look at my table of data, there's the 8, 12, 13, 1, 24, and you can see 8, 12, 13, 1, 24, right? And then the matched on the next list, I have the other set, the 10, 9, 16. So I've already entered all the data in my calculator. Okay, so then what we're going to do is use stat tests, and we're going to go to number 2, the t-test. On L4, which we're going to define to be L2 minus L3. Running out of space here. right? The set of differences, because in our null and alternate hypothesis, we were looking at the differences of the means. So what I'm going to do is I'm going to go over here to L4 and say, okay, go up so that I'm defining it and hit enter. Okay, so I can define exactly what L4 is, and I'm going to say, okay, this is going to be L2 minus second 3 for L3, and I hit enter, and it's going to give me a list of all the differences. So L4 consists of the difference between L2 and L3, or the difference between the bug bites for repellent A and the bug bites for repellent B. So then I can do my t-test. I have the actual data. The null hypothesis is that the difference is 0, and those differences were in L4. Frequency should always be 1, and I want to test and see, is there a difference? So I have not equal to, and I hit calculate. Okay, and I get a p-value of 0.0114. Okay. All right, and we notice that that's smaller than 0.05. So we're going to reject the null hypothesis. That means that we have statistical evidence that there is a difference. Okay, so that means that the mean number of bites for everybody, not just the 30 people in our sample. Okay, now something that wasn't specifically asked, that I kind of skipped over because it wasn't asked, was making sure that we meet the requirements for these tests. Okay, and to use a paired t-test, our and again, this wasn't asked in the question, so I'm just putting this on here as review. So in order to be able to do this test, what we need is that for both samples, we need that the samples are big enough. That means either bigger than 30 or approximately normal with no outliers. Okay, and we need the samples to be random, and we need the populations to be big enough. But these are the main things. Sample size is big enough. In our earlier problems, we needed the same thing. So in this question, it says that it comes from a population that's normally distributed. That's important because we only have 10 items here. Okay. Well, and then in number 1, again, we have the 30, so we have at least 30. The other one that I want to check the requirements for real quick is for problem 2, just going back a little bit. If I have yes-no data or qualitative data, the requirements are a little bit different. In order to say that the sample size is big enough, I need the formula np1 minus p to be greater than or equal to 10. Okay, so in this case, my n is 1006 times my p, that sample proportion I have of, what was that? 0.13, let's use 0.13, times 1 minus 0.13. And if I compute that out,